name is Avri Doria, and I'm going to be giving a talk on a brief history of code protocols and standards, of regulation and the internet, and on human rights in the internet. This talk is prepared for EuroSig in Meissen 2024. The first assertion I'll make is without code, protocols, and standards, there is no internet. It is what the internet rests on. We'll get into that a little bit more. And then we look at, well, once you have code, protocols, and standards, you have an internet. How is it governed? Who makes the regulations? How are they made? And that becomes the second bit of history that we're going to go through. And then finally, once you have figured out how to govern this thing that you build, or at least you figured out that you need to govern this thing that's been built, what about the users? What about the rights and human rights of those that are using it? That will basically be covering the three strains that we're looking at. So we have a rough history. I include a telephone, a rather old, nice telephone, up in the corner there, just so that remember that this internet did not come out of nothing. There were existing things. There was a telecommunications environment that it sat on top of. So basically, while it started earlier in the 1970s, code, protocols, and standards really were being worked on in a very big way. And there was a lot of focus on building a lot of code, building systems, systematizing the systems, defining protocols that would interoperate with each other, and developing standards to assist in that interoperation. Then in the 90s, once, once this network had been built, there was a trend to look at, well, how do we maintain it? How do we govern it? How do we do that? And so started to have a lot of issues there on both the national and international level in terms of who governs the internet. And then finally, this century, we started to look at it. Now that we've been talking about governing it, are we taking into account the human rights of the users? The human rights of those that develop them? How do we govern it without an awareness of how human rights interact and are affected by the internet? So taking these three lines of history and doing a very rough and cursory history in the time I've got here today, basically lead us to the internet of today. There are a lot more threads of history that feed into the internet of today. And the internet has continued to move on. And in fact, what comes of the internet of today, what the internet of today looks like, how it works, and where it's going, will be very much the subject of the other classes you take in the program. So moving along. The first thing is trying to understand the internet. How can the internet be understood? There are many ways. One of them is to basically link it to things we already know. It was a telecommunication system, or at least it looked like a telecommunication system to many people. It looked like media. There was publication of articles, of news, and whatever. So perhaps it's media. Then again, business was being done on the internet, business directly. There's business to business, there was, etc. So it was perhaps it's trade and should be looked at as a matter of trade. In each of these instances, there would be a different set of governance rules. There would be a different set of rules that apply to how you do this thing. What makes it work, what makes it not work, what makes it legal, what doesn't make it legal. What are the norms? And these are each different. So does the internet conform to one of these? Does it conform to all of them? In what way should the internet conform to the norms and rules of society? There's also looking at it as sort of a new sort of thing, that while it has a behavior that's similar to those, it has its own rules. It has new rules. It requires different kinds of regulation, and it requires a new analysis on how it works, on what it is. So taking those two views, one, you look at the internet as a thing in itself. Is it something new? Is it sui generis? Or are you taking the previous view that says, no, it's nothing new. It's like everything that we've already had and already knew. So if you take the view that it's like what we know, we can use our pre-existing knowledge structures. We can try and understand it by analogy. It's like telecommunications. It's like media. But these explanations will always fall a bit short because being like something is not being something. Being like two different things makes it a third sort of thing. So, but they're important in that they provide clues on what kind of things to look for. I prefer to define the internet as a self-healing system composed of a boundless complexity of code, created in a novel political environment, a thing that continually captures and recombines human intent and know-how, a system that can behave dynamically to produce an unlimited number of unexpected new possibilities. Certainly that bonanza of unexpected new possibilities, we've all seen it in the internet. We may not all always be happy with all of the unexpected new possibilities, but we cannot deny. We can also see that it does heal itself. The internet, through horrible occasions, through wars, through pandemics, through whatever, it persists. And it heals around the places that it breaks. Talk about a boundless complexity of code. No one even knows how many lines of code there probably are in the internet. And of course, more are being created all the time. The political end of it was different. This was not an activity that was directed by the state. This was an activity that grew from the bottom up. There were people that invented it, they worked on it, they developed it. Talk a little bit about all of that as I go through this. And what it did is capture and recombine human intent and know-how. Each person that sat down to solve a problem by writing code, by developing a protocol, by creating a new application, was basically taking something that existed, taking code, taking a system on which to put it, and creating something new that they put on top of it. That combined their know-how with knowledge that already existed, and basically building this new thing. As I go through these slides, we'll get to some of those issues, but it's also something to look at as you go on thinking about governance of what is it at its base? What is this thing that you're talking about governing, whether you call it digital governance, internet governance, or any other name? What is it that you are trying to govern? Now looking at code, protocols, and standards. This is the history that I said really began in earnest in the 70s, though there were certainly some antecedents in the 60s and even before. I'm going to look at three different topics: understanding the internet, the principles underlying much of internet technology, and the relationship between code, protocols, and standards. We already talked a little bit about understanding the internet in terms of the two different perspectives. That's a thread that you need to keep in mind as you go along, as you learn new things about the internet, and you find yourself starting to understand it. In what context are you understanding it? Are you understanding it as, oh yeah, this is just like telecommunications. This is just like the law. This is just like, or are you really saying, what is this thing that I'm looking at? What are its essential features, its essential principles, etc.? So it's just keep that perspective. So then I'm going to move to the principles. These principles underlie much of the technology. They were perhaps more adhered to in the early days. In some cases, the code, the complexity has grown beyond some of these. But for the most part, I would maintain that those principles remain and underlie much of the technology that we have. So what do I mean by principles? Internet principles. And when I'm talking about internet principles, I'm really talking about engineering constructs. Something that gives the engineers who are building and working on this internet an idea of how to proceed. There is no blueprint. There is no design committee at the top that sort of says, ah, yes, this fits, that doesn't. It is basically these principles that guide the engineers into what would work and what might not work. It gives them a basis for making choices. I don't know how many of you code, but you know when you come to a problem that you're trying to solve with code, there's usually any number of ways that you can solve it. How do you pick to solve it? You know, there are trade-offs. Something may take longer, something may be quicker, something may run more efficiently, someone may require more care, etc. There are choices you make. They have to do with cost. They have to do with ease of development. They have to do with time to market. And as this presentation tries to show, they also have to do with human rights. Excuse me. They enable a distributed community of designers and architects to build a single, consistent system, a unified internet, a connected internet, without there needing to be an authority that says what can and can't work. Within internet principles, there really are two types. They're design principles and operational. This talk's going to look more at the design principles. The operation principles are things that are critically important. They're things that we all talk about to a certain extent within other parts of the course, but they're not part of this presentation. So, in looking at design principles, a certain number have been pulled out from internet history. The packet-based nature of the internet, the end-to-end principle, the pastel robustness principle, the layered architecture, hourglass model, which is really a specialization on layered architecture, shared fate as a management principle, creative anarchy, and variation in outcome. Let me go through each of these individually. So the packet-based nature of the internet was first discussed in the 60s by Kleinrock, Bahram, and Davies. It was a way to move away from the centralized notion of the telecommunication system, where there was a hub, there were spokes, there were other centers around, but basically everything was built in the center. When you wanted to add new connections or new functionality, the center had to support it. The center had to bless it and push it out to the edges. It wasn't something where a creator could create. So this new model of a packet-based network where people built little networks, people built their own systems, and then they connected these networks to each other, allowed for a configured network of networks where each network handled the datagrams, also called packets, using best paths, but using the same methodology. This was what was in the code and the standards. In other words, they'd be separate networks, but they'd be using the same technology so that they'd be able to talk. This allowed for development of a network with emerging properties. If somebody in this network builds a new feature and this one in this network is willing to support it and they agree on how it's done, then you have a new property in this network. You did not need to go to a central committee to get that established. The end-to-end principle. This was the original quote on it. The function in question can completely and correctly be implemented only with knowledge and help of the application standing at the endpoints of the communication. It means that you need to build an application or a program of some sort at which all of the functions that are necessary to implement this are available at that particular end, at that particular edge. Now, it doesn't mean that all of those have to exist at that point. And in fact, there is a corollary to this that sort of says functionality that may be useful for many things can be deeper in the system as long as the end system you're at has proper access to it. And so if something is more useful, you can move it down. Now, part of the trick with the end-to-end principle is identifying what is it you need at the end? What is it that you can move down to other edges within that system so that things that are useful to a lot of problems, applications, and such are available. And another question is, to what extent is the end-to-end principle still in effect in today's internet with cloud-based and with other intermediate protocols that get in the way of the ends talking to each other directly? It's a question I'm not going to get into. It's a more advanced question. But when looking at the internet, look at it and sort of say, to what extent do we still have end-to-end? So it was first defined in the 80s. As I've said, it's often used in political discourse. It's often misused. It is often misunderstood. The principle focuses on putting information at the appropriate place in the internet because there are edges all the way through the communications. So for an application, yes, it is at the user interface. But if you're building a routing system, that knowledge doesn't need to go to the user interface. It can be hidden from the user as long as the user has access to the functionality provided by the routing. It does not speak of putting all the intelligence at the top, at the edge, nor does it speak of a dumb network. You often hear people saying, yes, it's all intelligent at the edges, all the intelligent is the edges, but the network is dumb. The network is not dumb. There's an incredible amount of intelligence. And this is not artificial intelligence. This is network intelligence that's been put in there by the people building the code for the last half century. So, moving on. Pastel robustness principle. Be conservative in what you send and liberal in what you accept. This was documented in the earliest protocols in the transmission control protocol. And it was an important principle in building networks. It meant once you've got a protocol established, try and use it as precisely and as carefully as you can. Be very strict in how you use. Be very strict, polite in how you use the protocols. However, if somebody's talking to you and they've given you all the information you need to be able to implement the function that you're trying to implement between you, but there's also some surplus information that may or may not be correct, then you have a question. Do you interoperate with them even though there's stuff that may not be right? Or do you say, no, if it's not a perfect packet, I won't process it? This comes into then a question of one of the trade-offs you get is if you're building a network and you want to get it to work, getting it to work as quickly as you can, even if there's some issues on the edge that are not solved, get you a network quicker. On the other hand, by leaving that unknown information on the edge, you might be creating security risks for the future. When you hear of somebody going and looking for a day zero exploit, what they're looking for is some place where someone wasn't conservative and someone accepted information that wasn't conservative, and they basically left a vulnerability. So it's important for building a network, but in the long run, it can be a risk. The layered architecture. A layered architecture is one where data moves from one layer to another and is subject to different form of processing at each layer. What that means is, for example, your email application doesn't have to understand the whole network. The email application does not need to understand how data is transported from one system to another and across the network. Your application does not need to understand how addresses are used to locate the places. It doesn't need to understand how Wi-Fi works or how Ethernet works. It's enough that it understands how to take the data that is in your email, to encapsulate it in an envelope that the application builds, that then passes it on to a transport layer that knows how to get to where you're going, that then passes it on to an IP layer that knows how to get to the next system in the line. You may know you're going there, but it knows how to get you the first step. And then to the electrical. What system are you on? Are you on a Wi-Fi? Are you on an optical? Etc. So these things are all taken care of at different layers. You take the data, you encapsulate it in an application. It then is passed to a transport that understands the address. It is passed to an IP that knows how to route it. It is passed to a link that knows how to turn it into electricity, into pulses, and pass it on. It's layered. Hourglass model. It's basically a notion where instead of thinking about it in its many layers, whether it's 3, 7, 9, you're thinking about it in terms of really two separate zones. You have a top part of the hourglass where the applications run. You have a bottom part of the hourglass where the infrastructure is dealt with, where the hardware, where it passes physical. Now, you find that in the IP internet, that the IP, the internet protocol, is the waist of that hourglass. It's where the top of applications and the bottom of hardware come together, so that application people don't need to understand how the infrastructure works, and the infrastructure developers don't need to worry about what applications do. And here's sort of a picture of that model in history. When it started out, it was very strict, had a very narrow waist when it was young. There was a single IP, and such, and there was end-to-end. Things went from the TCP/UDP layer to IP, and then to the physical. These days, you look, and the waist has perhaps no longer quite as narrow. Not only do we have two kinds of IP, we have V4 and V6 that, have to share space, have to work in the same systems. We have middle boxes, whether it's for streaming video or music or accounting or virtual private networks or something like that. You've got a system in the middle that sort of breaks the IP connectivity so that you have an IP here and an IP there with something operating between them. So it's different, yet it's still that model. There's still this notion that there is some stuff at the top that's application-centric, perhaps even human-centric, that needs one kind of understanding. And then there's the access methods and the methodologies, the technologies that they rest on below, and that the two have to be connected by something that understands both, but they don't need to understand each other. Shared fate, as I said, was a management principle. In some networks, and networks of old in the telecommunication system, you really had two networks. You had the network that the phone system was using, and you had a control or management network. These two were run separately. They were completely different sets of protocols, completely different fates. One could break while the other one kept working, or vice versa. So, in shared fate, it means that the control information is traveling on the same network along the same transport mechanisms as the data itself. So, if there's a problem with the data, the management will notice it right away because it doesn't need somebody to report it. It will stop working itself. It will know something's wrong because something happened within its own communications. Without the assumption of shared fate, you need the management system I talked about. This has been fundamental in routing design, but this was also broken by routing design. Once we came up with multipath label swapping and PLS, people started building tunnels. They'd have these places where that shared fate assumption wouldn't necessarily hold anymore. So it created new difficulties and created the necessity for building various management layers. The notion of creative anarchy, also called the generative nature. As I said, there is no top-down design. The principles and creativity instead of a design committee. As long as you stick within the guidelines, as long as you follow the mandates of interoperability, anyone, anywhere can still contribute something new. You need to be creative, you need to know how to code, and you need to pay attention to the underlying principles of the internet. This has been credited for the invention of almost all the new application models, such as wikis and social media, and the applications that are used in medical science, those that are used for reporting on the weather, etc., email systems. Those are all built by people, and then if people are interested in them, if they're good, more and more people use them, and that become. So it is one of the foundations of the growth of the functionality one can find on the internet. But likewise, as argued by Jonathan Zittrain and ITU and others, it's also responsible for spam and viruses. If I can create anything I want, and I don't happen to be someone that wants to create wonderful new things that makes people's lives better, but I want to create nasty things for whatever purpose I may have, that's possible too. And that then leads to much of the need we have for creating security systems and for finding ways of developing trust on the internet. The whole security and trust is something that you will talk about a lot in the upcoming sessions. So it's not something that I will get into. But in some respects, it is this generative nature that requires that you worry about security and trust. And hopefully you can do so without losing that generative nature. Finally, there's variation in outcome. Variation in outcome is basically something that sort of said, because you build it to do a particular task, doesn't mean that that's what it would be used for. If things are going to have a long-term purpose, if software is going to aid in sustainability, then software needs to be, and other systems, they need to be flexible. They need to be able to take on new duties that weren't conceived of at the time that the original code was built. And that sort of leads us to sort of a quote that came out that sort of says, so that the outcome can be different in different places, and the tussle takes place within the design, not by distorting and violating it. What you're saying is, there's a tussle, there's a battle between the old and the new, that what can something be used for, its flexibility versus its solidity. Don't make that an impossible. Do not design so as to dictate the outcome. Build capabilities. Rigid designs will be broken. Designs that can permit variation will flex under pressure and survive. If you look at the history of applications of software within the internet, you'll find that the ones that still exist, that were there at the beginning, are those that were most flexible, that could change as it was needed. And I know as a protocol designer, as I once was, I designed a system that didn't get used for what it was built for, but was eventually used for something far more important, far more extensive. It really is in the nature of the internet that things are used flexibly, things are used creatively. Okay, so then moving on to the next part of this. Code, protocols, and standards. How do they relate? I've talked sort of loosely about, well, someone writes code and it's a protocol, and then, you know, there are standards and people use standards because they want to interoperate. And very much, you know, hand waved on that, but a little bit more into looking at those. So what is the relationship between protocols, code, and standard? When I was talking, sometimes I'd say there'd be code that someone wrote. Sometimes I'd say they'd use a protocol. Which came first, the code or the protocol? Or was it indeed the standard? And that really depends on which standards development organization builds it. In some cases, you have a protocol that turns into a standard, and then once it's blessed, people code it, and then once they see how it works, they update it. In another case, a bunch of people figure out a standard, and they figure, and that's basically, what do we need to do? What do we need to standardize? How will this work? How will this look from one system to another? Then they build a protocol that sort of takes all those, how will it look, and makes them precise, defines them, so that the coder can then code. And once it's coded and people go, then they'll update the standard to sort of say, oh, we wanted it to do this, but now we think we really want it to do something more. Or there's just existing code, it's been built, it's been doing a task, it was handy, and people used it more and more, and all of a sudden noticed people that were using the code differently and it wasn't consistent, and we should really write down the protocol. You know, how does this code work? You know, let's write it down and systemize it so that new people can build it without having to reverse engineer. They can follow instructions. Then that often leads to a lot of discussions about, I wrote my code this way. Well, I wrote my code that way. And people talking and coming out with improvements in the code so that they can interoperate. The protocol gets updated and the motion continues. So there are many different ways to work it. I won't argue that either one is correct or not correct. It really depends on the job you have to do. If you have a specific contract that says, we need something that does this, then perhaps you're better off defining a standard of what this is so that you can define the protocol. If you're building a system that says, we want to communicate openly and interconnectedly using the alphabet and using characters that are not ASCII, etc., well, then you have a bigger problem, and you can't just define the protocol. You experiment with code, you experiment with protocols, and things progress sort of in cycles. It really depends on the work that you need to do. So code itself is at the base. Code is bit and byte centric. In other words, the ones and the zeros, or the collections of ones and eight, you know, 8 bits of ones and zeros that form a byte, and each of these things has a meaning. When you're doing a code, that one, that true, that false has a meaning. The code that you write is very much the prototype for many protocols. You know, someone creative sits down, starts writing code, and proceeds from there. Many of the protocols that are written, though not all, are implemented in code. No matter what a standard says, the code of the dominant player often becomes the de facto standard. And so you can have standards, you can have that, but you'll find that very often a standards association will go back and say, hey, we designed the protocol this way, but life out in the field and the reality of the market and the reality of politics, the code now works this way. And the standard or the protocol will be updated to match reality. Code is very much affected by the robustness principle. You decide. Each person writing a piece of code on one side decides to what degree they want to be conservative and to what degree they want to be strict. It's advised by the principal to be as strict as possible with what you send. Write your code as clean as you can. Don't take shortcuts. Then again, when you're receiving something, do you really want to try and impose that same strictness on someone else? Or are you willing to work with what you got and try and make progress over time? Code instantiates protocols. It makes them real and often becomes the de facto standard, as I've said. Protocols in the Stauffer sense. In order for two network entities to talk to each other, they need messages that are part of an ordered set. You say hello before you say goodbye. That includes response mechanisms. I say hello, you say hello to me back, and I say thank you for saying hello to me back. We had an ordered set. We know how to talk to each other. It has a strictly defined syntax. In other words, however you're going to use the statements, however statements you're going to have, you need to use them as they are written. You need to use them in an order that's been defined for them. It doesn't do in that interaction that I made before where I say hello, for you to say hello back to me before I've said hello. And it has semantics. Again, going back to the bits and the bytes. Every sequence of bits and bytes has a particular meaning, and that meaning is defined in the protocol. In other words, just bits on a line, you're guessing. What is this doing? What are you doing? Perhaps there are comments in the code, perhaps there are not. But often if you just read code, the semantics aren't there. It's the comments in the code, but it's the semantics defined in the protocol that tell you what those things are doing. So, but where do protocols and standards come from? And we talked a little bit about this already. Some are produced independently and become de facto standards. Whether I, as an individual, write something new, put out a protocol, build prototypes, give people, open source code, and it becomes a de facto standard for some great new application that is done, it works. In other cases, there are standards development organizations that take some problem, have some task, have some view of the world where they design protocols and standards. And anybody that wants to follow the same pattern that they follow uses those standards. Standards are the link between protocols, the internet and internet governance, and the standards development organization where it happens. But what is a standard development organization? Is there just one kind? And again, the answer, like almost everything in the internet, is there's more than one way of doing it. There's more than one way that's acceptable for doing it, but not always will work. So you can have an intergovernmental institution authorized by treaty or otherwise to create standards that may be either mandatory or voluntary. You can have an industry body that creates standards that are used by its members and creates requests for product, RFPs. You could have an ad hoc grouping of experts that creates standard tracks proposals that only become standards when adopted by the market. You could have a private entity that uses contractual conditions to impose its policy standards. These are all patterns that are used in one extent or another to build standards organizations, and they build quite effective standard organizations as long as the right methodology is mapped to the correct problem. Standards in the social sense. The wonderful thing about standards is that we have so many of them to choose from. This has been one of my favorite quotes for a long time, and yet I've never been able to figure out exactly where it came from. I have found all of Grace Hopper, Ken Olson, or Patricia Seibald, all leaders from the earlier network, to have said it. And I can't find anything definitive that tells me which, so I've accepted that this statement comes from many. Standards equalize the playing field. When you have standards, You know that at least to some extent, at some basic level, you're all doing the same thing and you can be compared. You can trust that when you buy an email program for the internet from one company, it will work with email programs from another company, at least in terms of sending messages. So we need that. Users need standards to know how to use an application. Competition requires standards. We need to be able to build a basic internet that we can all use effectively before we start building the pretty and wonderful bells and whistles that sell our product as differentiators. But a differentiator does not work if there isn't a base, a solid base from end to end to build on. Standards can limit innovation sometimes. If the standard says you can't do this because it's dangerous, well, then that limits. But by and large, they also enable innovation. Once you know what you can and can't do, it lets you focus on the places where there is leeway, where flexibility is beneficial. So again, like everything else, it depends on the kind of standards. Then the question comes up, so who should make standards? Whose role and responsibility is it? Talk more about that as we move forward. I figured a cartoon was good. We have a situation where there are 14 competing standards. 14 standards. That's ridiculous. We need to develop one universal standard that covers everybody's use cases. Yeah, that's a good idea. Situation, there are now 15 competing standards. Humor, perhaps, it is existing. And, you know, there's a line up here, subtitle, C, AC chargers, character encodings, instant messaging, etc. Moving on to the next section of this. A trend that really became popular in the 90s, dealing with the maintenance and governance of this internet that has been forming and has been growing wildly. Internet governance. This is something that you may have already heard and read. It's something you'll probably hear often. It's a very versatile and flexible set of words. A working definition of internet governance is the development and application by governments, the private sector, and civil society in their respective roles of shared principles, norms, rules, decision-making procedures, and programs that shape the evolution and use of the internet. This originally came out of the Working Group on Internet Governance and was reinforced by the Tunis Agenda. The question that one asks is this enough to build a sustainable and fair regulatory framework? In other words, people were calling the internet, I think in its wild generative nature, the disparative that people got is, it's a wild west. The internet is a wild west. We need to come up with a regulatory framework. And ever since then, there really has been a lot of attempt to come up with a fair regulatory framework that would not limit creativity and yet would limit risk. It's a working definition. You'll run into working definitions periodically. It means that no one could really come to a definitive end of the line definition, partially because the internet is still growing, it's still evolving, we still don't know what it will eventually become, though we can understand what it is now. So perhaps the definition needs to be flexible. And you know, as people work together, the definition includes the stakeholders. It includes that notion of there are stakeholders, that governments, private sector, and civil society work together. At that time, they did not include the technical community and academia as separate stakeholder groups, but rather they said that people in governments and private sector and civil society could have the attributes of being of the technical community or being academic. As time went on, that changed. Of shared principles, norms, rules, decision-making, procedures, and programs. Those words apply to everything from coding, as we just talked about with code protocols and standards development organizations, to policymaking, to governing. So those words are very flexible and they have meanings in many fields. We'll look at a little bit of that as we move forward. And we're shaping the evolution, which is one of the reasons why it's hard to have a definitive definition. But it is a useful definition and it works. So, looking at some words. In English, a protocol is a code of correct conduct, forms of ceremony, and etiquette. In network engineering, a protocol is a set of rules determining the format and transmission of data, as we've spoken of. A standard is any distinctive flag, a reference point against which things can be evaluated. As you can see, there's sort of analogous and parallel definitions. A standard is a formalization of a protocol or a practice. A code is a set of rules or principles or laws, especially written ones, in English in the legal system. A code is the symbolic arrangement of data and instructions in computer programs, the implementation of a protocol. So the same words are used in different contexts. I took English here. We could use what do those words mean in political science? What do those words mean in governance theory? What do those words mean in psychology, etc.? And look at the parallels and look at the analogous meanings that we can use to draw on when we're trying to understand something. Regulatory frameworks. You really have certain notion. Do you have a framework or do you have a strict set of regulations and laws? Regulatory frameworks tend to be official rules and the act of controlling. Regulations are norms, rules, and decision-making procedures. Again, the words in the working definition. When they are adopted under an authority granted by statutes, they are enforceable under the law and often include penalties for violation. That is not the notion that we use them within the internet. We tend more to look at a regulatory function where there are rules and norms. They're created, one looks for compliance, one looks for enforcements of types, and one looks to be justice. So there's a tussle in internet governance between functions that come from states that have strictness. You can have compliance that says you're going to go to jail. You can also have compliance that says, I'm going to fine you. You can have compliance that says you lose access to this and such. So you really need to look at who is creating the regulatory functions and how are they administered and how is compliance assured. In this tussle between who creates the rules, we've very much gotten into, and I'm sure this will come out in future discussions that you have at the EuroSig, is, are we using a multilateral model? Are we using a multi-stakeholder model? And can the twain between them ever meet? A multilateral model is very much the description we use when we're talking about governments, the UN, treaty organizations, even the ITU to a large extent. In touch of it's states, it's governments, it's representatives of the bureaucracy of a government who meet together, who discuss all the issues. They talk to the home country as frequently as required, and they come to agreements. Through these multilateral negotiations, with a lot of bilateral negotiations on the side, they come to full consensus, and then the countries ratify it, and they make it a treaty or a set of multilaterally agreed rules that everybody has to adhere to. You have the multi-stakeholder model, where essentially a group of people got together and using various different methods, from voting to blackballing to talking incessantly until everybody is convinced, etc. And you come up with various methods of making decisions that are Not necessarily a full consensus with everybody agreeing absolutely, but a good enough consensus so that everybody is willing to say, yeah, I can live with that. I can work with that. I understand that you and I have a different view on this, but if we do it this way, it looks like we'll both be okay. We can both live with the answer. And this comes up with a different set of decisions. So the tussle between the multilateral control and multi-stakeholder management is far from being resolved. Talk about it daily. But does it really matter? If there is compromise between the methodologies, if the multilateral and the multi-stakeholder can work together, understanding each other's limitations, understanding each other's composition, is it possible that the two can work together? That's an open question that's being talked about, and you may get into it some more later in your week. Can multi-stakeholder models help in multilateral? Likewise, can multilateral understandings and methods help resolve some things in the multi-stakeholder world? Are there methods that can be shared between the two worldviews that make them less dissimilar, that make it easier for them to find compromises where both the multilateral entities, the states that feel they have a responsibility for public policy, and the stakeholders who have a stake in what kind of internet we build, can work together. Some of the words on multi-stakeholderism. We talk about multi-stakeholderism and we talk about multi-stakeholder models, and as time goes on, it becomes a charm. It becomes a badge that one can wear. Says, I'm multi-stakeholder too. And we do that a lot without really understanding, well, what does it mean to be multi-stakeholder? Yes, it means all the stakeholders can participate. But what kind of participation? Do you ask them their advice once every 5 years? Is that multi-stakeholder? Or are they in there nitty-gritty and making the decisions at the end of the day? Where do the stakeholders participate? How are the models built? We also talk about multi-stakeholders as if there's one model. Are you using the multi-stakeholder model? Well, I'm using a multi-stakeholder model. So when you're looking at multi-stakeholders, look for what's underneath the table. What are the modalities that this table of multi-stakeholderism, the study and practice of various models and forms of participatory democracy, what are the modalities it rests in? And also look at it. There are a number of models. How do the different models compare? How do they work? How do we understand the similarities and the differences between them? Have we developed a language or an understanding of what it means for something to be multi-stakeholder, to have a multi-stakeholder model? As I dive into these things a little deeper, I sort of talk about aspects. What are the aspects of a governance system that matter? Now, in this example, I've only picked 3. There are more, still looking into them. But basically, looking at 3 component aspects that are always part of a multi-stakeholder model to some extent. First of all, is the orientation of the model. Is it top-down? Is it bottom-up? Bottom-up means the ideas come from the stakeholders and the participants themselves. Top-down means there's some authority, a customer, a state, a boss that says, this is what you're building. Or is it a bit of both? That the bottom-up comes up with an idea, it passes it to the top says, cool idea, but might it be better if you did this? The bottom takes it, chews on it some more, etc. Or vice versa. The top maybe have an idea and say, hey, how about we build a thus? And the people at the bottom say, well, I'm not sure about building a thus, but we would like to build this. And the top says, oh, okay. And through emotion, the bit of both, a bit of bottom up and top down, eventually the orientation is come up with. Orientation. Participants. Been talking about stakeholders. You can't have a multi-stakeholder model without stakeholders. But how do you understand stakeholders? Very often, as has been the example so far, we talk about stakeholders as belonging to a group. Are you one of the states? Are you one of the private sector entities? Are you a civil society organization? Do you belong to a group? And it's sometimes something that I even think of that could be called multi-stakeholder groupism and not just multi-stakeholderism, but that's really too difficult. So we look at the stakeholders that they can be groups, as was determined in the Tunis Agenda. There were groups. They can be entities. For example, you might have, oh yeah, we're people that sell names. Oh, we're people that are register names. We're people that deal with the intellectual property issues. We're people that deal with the human rights issues. We're people that look at how the users behave. We're entities, or it could be affinities. We're a bunch of professionals. Well, I look at the world through legal eyes. Well, I look at the world through philosophical eyes. And we have affinities. We tend to look at the world in similar ways, so we group ourselves. Or you may indeed have individuals. It really doesn't matter what affinities you have, what group you have. You participate as an individual. This, for example, within the IETF, but we'll look at that more. Then the other part that gets discussed a lot in many different ways is roles and responsibilities. Who decides? I mean, that's the first one that comes up with when you look at roles and responsibility. Who's the decider here? But you also look at, well, who contributes? Who does the work? How do you get to the point where you have something to decide on? Are you deciding out of the blue? Are you contributors? And then there are people that are neither deciding nor are they actually contributing. They're giving advice on various principles. They're making recommendations on specific ways of doing things. And this is, again, just four. And you look at that and you sort of say, not only do these roles vary and who, is responsible for doing what, but these things vary at different stages of a process. At times, you're at the beginning of a process, and everybody is sort of milling around, and people are throwing ideas out, and people are writing a little bit of code, and somebody's writing a document, and somebody who's a specialist at the way things work, at scalability, looks at it and says, oh, that would never scale, and they advise and permutation. Then there's decision makers. Now, which stakeholder group fills which role at which phase of a project is something that varies in all multi-stakeholder groups. There is very few groups I can think of, except maybe the IETF, but very few groups I can think of where the roles are, any stakeholder can have any role at any point in the phase. It's not common, it can happen. So then when you're looking at stakeholder groups and you're trying to determine, are they multi-stakeholder models that are similar? Are they multi-stakeholder? Do they have all the features of a multi-stakeholder model that we think are required? And so, this is just a quick example. I'm not going to go through the boxes because that's not the point here. This is a good exercise to go through and look at it. This was, done several years ago. It may or may not be true anymore. This is the kind of thing you draw up as an exercise. I took 3, ICANN, IETF, and ITU, 3 that I sort of knew, 3 that I've worked in, and try to determine what is their orientation, who are their participants, how does that work, and how does roles and responsibilities work, and this is very abbreviated, but it's the kind of analysis that leads you to doing more than just saying, I'm multi-stakeholder. No, you're not. I'm multi-stakeholder. Oh, you can't talk to those people. They're just multilateral. Yeah, but they do this. That's a multi-stakeholder process. Yeah, but they're a multilateral organization. And basically gets you beyond that initial, what cover does the book have, but look into the book and see what kind of modalities, what kind of methods are used. Now, going to the section on human rights considerations. So we've built code and protocols. We have internet out there. We've got people using it, people investing their reputations, their names, buying names, using names, building businesses. We've got regulatory frameworks. We've got governance of various sorts. We've got multi-stakeholder organizations and multilateral organizations all talking about how we're going to run this thing, how we're going to make it work, how we're going to make it useful and trustworthy for the users. After all, when you get down to it, it's very important, the stakeholders that build it, but a key stakeholder is the user, the end user. The how is this thing going to be used? And when you start talking about people, when you start talking about a human-centric internet, which is the language these days, you start looking at the human rights considerations. And as how do we have to deal with this and support and respect the human rights that people have? So, in this section, I'm going to talk a little bit about the human rights background, and then going to give a very quick peek into the IETF and IRTF and how they're looking at human rights, and again, a little peek at ICANN. In many ways, this is work that's ongoing, that is something that has room for everybody that's listening to this to get involved, because this is one of the areas where new stuff is happening, other than, of course, AI and cyber and all of that. Human rights. That basic discussion usually gets rooted in the Universal Declaration of Human Rights in 1948. Now, this is a non-binding treaty. However, it has sort of formed the foundation for a complete set of binding instruments that have been created by the states over the years. Covenant elimination of discrimination, racial discrimination, covenant on civil and political rights. I actually wrote convenient. I should fix that before I give this again. International Covenant on Economic, Social, and Cultural Rights, Convention on the Elimination of All Forms of Discrimination Against Women, Convention on the Rights of Persons with Disabilities, and many more. You'll see a list on the next slide. Then there's the UN Human Rights Council, in 2012 affirmed that the same rights that people have offline must also be protected online. In particular, freedom of expression, which is applicable regardless of frontiers and through any media of one's choice, in accordance with Articles 19 of the Universal Declaration of Human Rights and the International Covenant on Civil and Political Rights. That was very important, because for a while there was an assumption that human rights apply to humans wherever they are, there was also this notion, well, if you're arguing that this is sui generis, then perhaps human rights don't apply here in the same way that they apply everywhere else. That perhaps we don't need to respect them here. So it was a very important moment when the Human Rights Council said, wait a second, we're the ones that are working with these human rights, and whether it's in the physical world or it's in the digital world, the rights remain the rights. They may look different, they may be instantiated in different ways, but human rights are human rights. Here's just a list of some of the key treaties I've already listed. Convention on the Rights of the Child. There's a UN Special Rapporteur on freedom of expression. There are actually many UN Special Rapporteurs on each of the freedoms. In 2015, governments should promote the use of strong encryption and protect anonymous expression online. So here we're looking at the role of states in respect to users, and sort of, governments, tell users that they can use encryption. Make it legal for them to use encryption. Don't make it illegal for them to use encryption. 2016, private entities should ensure the greatest possible transparency in their policy, standards, and actions, and implicate the freedom of expression and other fundamental rights. It's companies, when you're building stuff, be transparent about it. Be open about it. Let us know what you're doing about the freedoms. Let us know how you're protecting our rights. Private entities should also integrate commitments to freedom of expression into their internal policy making, product engineering, business development, staff training, and other relevant. Companies, you yourselves need to behave with human rights towards your stakeholders, towards those who work for you, towards how you train your staff, etc. You need to keep human rights in mind throughout your entire process at each stage of the work you do. Then it's looking at, well, okay, we've said human rights are relevant to users, but what about when I'm writing code or writing protocols or developing policy? That's different, right? That's governance. Governance and human rights. The Tunis Agenda in 2005, we reaffirm our commitment to the freedom to seek, receive, impart, and use information, in particular for the creation, accumulation, and dissemination of knowledge. We affirm that measures undertaken to ensure internet stability and security, to fight cybercrime, and to counter spam must protect and respect the provision for privacy and freedom of expression as contained in the relevant parts of the Universal Declaration of Human Rights and the Geneva Declaration of Principle. So here we're saying, you've got to make it safe, but also within your governance schemes, when you're talking about how to go about things, you also have to protect privacy. That you cannot sacrifice one for the other. Makes it a harder job. Makes it a more exciting job, perhaps, but you really can't sacrifice one. And then in 2014, there was Net Mundial that basically established some principles. You'll be talking about a Net Mundial plus 10 in your later work that gives some guidelines for these. I'm not going to get into that. That was just a quick peek at something that may be ahead of you. But in Net Mundial principles that human rights are universal as reflected in the Universal Declaration of Human Rights and should underpin internet governance principles. So here we're making a definitive statement. It might have been obvious before that if human rights applied to the internet and applied to the user, they also applied to its governance. But whenever there's an ambiguity, it really is important to plug it up because someone will drive something less than wonderful through that ambiguity, sometimes even malicious, sometimes an error. Rights that people have offline must also be protected online. We've heard that before. In accordance with international human rights legal obligations, including, and then a list of the rules. It's basically to remind us that our rights are the same offline and online. How do we make that work? Finally, in the last year, the Office of the High Commissioner for Human Rights wrote a report, Human Rights and Technical Standards Setting Processes for New and Emerging Digital Technologies. This particular paper sort of brings together the three histories that I have been sort of talking about briefly here in terms of human rights pinned to standards development processes, to SDOs. Human rights considerations, an integral part of standard setting processes in terms of inclusive participatory processes and assessing human rights impacts more systematically. So basically, this is coming down to you've had all the theory, you've had the principles, you've got the covenants and the guidelines, but how do you get it done? So here's giving a little bit more of an indication of how to get it done. So, talked a little bit of human rights, now going into IETF and IRTF. A few acronyms. IETF, the Internet Engineering Task Force. The IRTF, the Internet Research Task Force. They're kind of like sister organizations. HRPC is a research group, Human Rights Protocol Considerations. RFCs, that's name for IETF and IRTF repository documents, and they come in various flavors. They're historical, they're informative, they're protocols. It used to be called Request for Comments. UDHR, Universal Declaration of Human Rights, it's long to write out, and the ICCPR, the International Covenant on Civil and Political Rights. So the fundamental question when you're looking at this is, are engineering decisions value neutral? when I talked before about those were all decisions that one makes, the trade-offs one makes when they're building a system. Are they all value neutral? For the longest time, certainly back in World War II and before that, engineering and science were always considered value neutral. That it wasn't good, it wasn't bad, it was value neutral. But when you start considering human rights among the engineering trade-offs, can that still be said? How do you design a protocol such that it's an enabler of human rights? Are you then saying that you're designing something that it ought not to be value neutral? It ought not even pretend to be value neutral. And when you're looking at a new protocol, should it be judged against human rights requirements? Is a protocol that's really good and really effective but evil something that we want? Or do you have to sort of say no when you're creating new systems, when you're creating new protocols? You need to understand the value of that and whether it is an enabler or an impediment to human rights. So how do you focus the efforts? Do you design it in? Do you measure the impact? Do you do both? Etc. Probably not neither. So the IETF looked at privacy, and defined security and privacy. In the IETF definition, those two are related. That you don't have security if you don't have privacy, and you don't have privacy if you don't have security. Trust by users in security and privacy on the internet is a critical part of its success. We have seen in the press, in elections and everything else, that if I can't trust what I get on the internet, what good is it? A range of components, including robust implementations, careful deployment, and appropriate use of security technologies, is required to create a trusted internet. Within the IETF, the security area is strong, has at least 20 active working groups that are enabling secure and privacy-preserving communication. And they're doing it at every layer. Remember we talked about the layering. Well, each layer has reasons for its own levels of security and privacy, and they need to be thought of separately. It's part of making the system harder to spy on if every layer has security that needs to be dealt with. It helps collect and verify, understand, and update the state of network endpoints in terms of their security, in terms of their privacy. It's providing protocols and applicable and applications the means to handle authentication, authorization, accounting of users, applications, and devices. So basically the security area is working intently, and in fact, is constantly dealing with this tussle that we've talked of between, do you make it secure? Do you make it private? There isn't a contradiction between the two. If it's not private, it's not secure. If it's not secure, it's not private. RFC 6973, Privacy Considerations. This document offers guidance for developing privacy considerations for inclusion in protocol specifications. So knows what they did is it's not enough to tell people, make it private. It's not enough to ask, did you think about privacy? What you really need to do is structure that conversation, and it was really the brilliance of this particular RFC to structure it into a set of questions, the kinds of questions that developers ask when they're developing something. Its aim is to make designers, implementers, and users of internet protocols aware of privacy-related design choices. It suggests that whether an individual RFC warrants a specific privacy consideration section will depend on the document's content. One of the things they interested, the IETF for a long time had a requirement for a security section on any protocol that was created. It doesn't yet have a requirement for a privacy section. Of course, that can be part of a security section. But what it says is, think about it. Look at this set of considerations that we've put in this document and think, is there a need to be specific, to talk about the considerations? Subsequent to that, and sort of following on its lead, was the Human Rights Protocol Considerations Research Group was created, taking that very good notion that had been developed by privacy, in privacy consideration, and looking at whether standards and protocols can enable, strengthen, or threaten human rights as defined in the UDHR and the other covenants. And so at this point it says, not just privacy, but the other rights. Can we build sets of considerations so that developers that are creating code can go and say, aha, these are the questions I need to ask myself. The research group took it as a starting point, the problem statement that human rights enabling characteristics of the internet might be degraded if they are not properly defined, described, and sufficiently taken into account in architecture and protocol development. Not protecting these characteristics could result in partial loss of functionality and connectivity. So the output of the HRPC research group has been RFC 8280. It attempts to bridge the language of rights and protocol technologists. One of the first things we found when we tried to bring together human rights advocates, social scientists, and engineers was that they spoke a different language. They didn't use words to mean the same thing. When you said freedom of expression to an engineer, while she might know what that meant in a general sense, like every human does, didn't know what it meant in terms of writing code or designing a protocol. They did an ethnographic analysis of the IETF RFC repository to look at all the linkages between values, morality, and different code points and code discussions that there were. And basically throughout the look of that came up with a hypothesis on the relationship between protocol elements and rights. This was really an extensive piece of work. And RFC 8280 does have a good description of it. Suggested considerations that protocol designers can use when developing or evaluating protocols. It's now being used, it's being tested, and trying to find out whether those considerations are indeed useful. Jury's still out. Just to give you a quick idea of the depth of the work, this is not something that I'm going to talk about in any depth, but took all of those words, and you'll find this in HRPC guidelines, all of the words that we use when we're talking about human rights and protocols and such, and looked at connectivity, privacy, content agnosticism, security internationalization, heterogeneity, pseudonymity, etc. There's a second page of them. Accessibility, localization, decentralization, reliability, confidentiality, integrity, authenticity, adaptability, outcome transparency, and anonymity. As I said, all concepts that we all have some idea of, words that we use, but each of a policy advocate or an engineer or a social scientist would look at those words differently. They'd have different definitions. So then we started to map them and sort of said, okay, when we're talking about freedom of expression, which of those elements that we just tried to define and outline would freedom of expression involve? Connectivity, privacy, security, etc. So we came up with a subset. Likewise, with freedom of assembly and association, connectivity, decentralization, censorship resistance, etc. Again, a set of those things that said, if you don't have those, then you don't have freedom of assembly and association, and built the considerations around that. Other topics that are being discussed at the moment, freedom of association, and we have ongoing discussions in standards in politics, anonymity, internet filtering, etc. And finally, to ICANN. And this one will be relatively short. ICANN is Internet Corporation for Assigned Names and Numbers. You will be talking about ICANN a lot over the next days. One of the things that comes out in this discussion is a framework of interpretation that was necessary for a human rights bylaw amendment that was created. The ICANN has a very strong commitment to the global public interest, and its board of directors must make sure that every decision they make, they've taken the global public interest into account. And then what we're constantly working on is policy development processes. So ICANN has articles of incorporation that are the promises to the state, and it has bylaws that define how it works. Within the promise to the state, the corporation shall, except as limited by Article 4 here, and that's the mission, pursue the charitable and public processes of lessening the burdens of government and promoting the global public interest in the operational stability of the Internet by carrying out the mission set forth in the bylaws. Such global public interest may be determined from time to time. Any determination of such global public interest shall be made by the multi-stakeholder community through an inclusive, bottom-up, multi-stakeholder community process. You can see, therefore, that in the foundation of ICANN, this whole notion of multi-stakeholder, bottom-up, community processes, global public interest, etc., are tied into the fundamental existence document of. Then you get to the bylaws that goes beyond that and starts talking about the scope of the mission, establishing core values, and among those is respecting internationally recognized human rights as required by applicable law. The core value does not create and shall not be interpreted to create any obligation on ICANN outside its mission. So ICANN doesn't go around punishing people or trying to create rights in water distribution, for example. It's beyond its mission, or beyond obligations found in applicable law. The core value does not obligate ICANN to enforce its human rights obligations or the human rights obligation of other parties against other parties. It means it does not have a role in regulating registries or registrars in terms of whether they treat their employees with proper human rights. This design, I don't know whether you see it, it's in the slides. Basically, similar to what was happening in the IETF, the ICANN looked at its policies and looked at all the rights involved in the various policies that it produces. It then mapped each of those rights to a theme. And then each of those themes was mapped to a specific policy or process. So this is the extent to which the work has been done, sort of trying to understand the work that ICANN does vis-a-vis human rights. This was made so that it would be a useful tool. And the document that was in this, and you can see a PDF address for it at the bottom. So I talked about human rights and the global public interest. The global public interest is what is defined in the bylaws and in the incorporation. And basically it's set forth shall have no force unless it's effect the FOI was created. So now there's a formal core value. Human rights has been defined as a core value with a specific scope and a specific methodology as part of the bylaws. And it is part of the definition of ICANN's global public interest component. It is therefore one of the configurations that the board has to look at. The board is required to take the global public interest into account with every decision it makes and must include an explanation as part of recording the decision. And for those of you that have ever read through an ICANN motion that has been approved by the board, you will find a rationale section that includes a discussion of the GPI, of the global public interest, and hopefully a discussion of how it bears on human rights, etc. Now, within the bylaws, there's also a requirement for a certain number of human rights impact assessments. And basically the requirement on ICANN there was to do a human rights impact assessment of its own existence as an organization, as a corporation. And when developing corporate or operational policies and executing its operations, ICANN, the organization, should take the human rights core value into account. In order to do so, ICANN, the organization, should propose a framework to the community which should include multi-stakeholder involvement in its development and regular review. And it goes on, ICANN's mission, commitments, and core values, including The human rights core values should be taken into account by the support organizations and the advisory committees and ICANN, the organization, when considering policy matters. The board will need to take into account ICANN's mission, commitments, and core values, including the human rights core value, in considering all matters before the board, which also includes advice given by the CAC. So this statement basically on human rights impact assessments and defining what they can look like sort of brings it all back in a loop, back to the beginning, back to human rights, back to what is developed. How are all these things linked together? Human rights impact assessments, more of them need to be written. Theoretically, one should be written for every policy development process where new policy is being created, and is that policy impact? How does it impact human rights? Does the policy? There have been several of those done. There was a sample human rights impact assessment for policy development process. That picture that I showed you before is linked to that sort of tells people how to do them. And one has been done for the System for Standardized Access and Disclosure and recommendations. So one has been done. It's an excellent piece of work, definitely worth reading. This is one place where there's a lot of opportunity for those who want to write human rights impact assessments, not just at ICANN, not just at IETF, but at any organization that is building policy or building subsystems, that is building platforms. Each of those should be running human rights impact assessments on every development it does, so that we're not hand-waving about, is this good for human-centric, is this bad for human-centric, but so that we know. There's a lot of opportunity for that. The IRTF also has a global access to the internet for all, very important to human rights, and they're constantly looking at how to enhance privacy, assessments and such. A bunch of references for what I talked about, the WGIG report, etc., and some IETF and IRTF references. And I thank you for listening to my brief history of code, protocols, and standards, of regulation in the internet, and of human rights. I wish you a wonderful week in your learning at EuroSig. Thank you.